Alright, let's look at another binary tree traversal, the so-called zigzag level order traversal. So we actually have practiced a number of traversal algorithms for binary tree, like the pre-order traversal, in-order traversal, post-order traversal, and level order traversal. So this zigzag level order traversal is a slight modification of the level order traversal. The problem states as follows. So given the root of a binary tree, we are required to return the zigzag level order traversal of its node's value. So in other words, from left to right and then right to left for the next level, and alternate between. So let's look at example 1. So in example 1, we first traverse the level 0, or first level, from left to right. We get 3 in the output, and then we reverse direction. We traverse from right to left for the second level, so we get 20 and 9. So we get 20 and 9 in the second item in the output, and then we reverse the direction again, so we get 15 and 7 from left to right. So that corresponds to the third element in the output. So with that example analyzed, so let's look at the code directly here. So as we mentioned that for the level order traversal, so basically the data structure corresponding to the algorithm is the queue. So here I want to do some slight modification of our previous code for the level order traversal to solve this problem. So you are encouraged to have a look at this video about the level order traversal. So here I will directly write the code because the step from level order traversal to the zigzag order traversal is just the addition of a counter. So first I will make some preparation and treat special cases. So I'm going to initialize a variable called result, so whose final result state is what we want to return, and also I want to initialize a counter called level, so initially equals 0. Then what we are going to do is that we check the special case. If not root, I'm going to return the result itself. Otherwise, I'm going to enter a while loop. So for that, I will first initialize a queue, so which originally consists of the root node itself. Then I'm going to do the iteration, same as the level order traversal in my previous video. So traverse or iterate. So here I'm going to, while the queue is not empty, so then I'm going to add the current values in the queue to the result. But I need to check if we need to add from left to right or from right to left. So for that purpose, let me introduce a temporary variable, though it's not absolutely necessary. But to fix the idea, let's do it like in this way. So I want to first track the values. So node value for node in the current state of the queue. Then I'm going to check if level is even or odd. So if it's even, so I'm going to add from left to right. So in other words, I'm going to append the temp itself. Otherwise, what I'm going to do is that I'm going to add the reverse of this temp. So in other words, we are going to add from right to left. So that's the slight difference from the standard level order traversal. So now, after we add the current state and the corresponding values to the result, we are ready to reset the state of queue. Let me use the list comprehension again. So the queue will be updated as this: for child, for node in current queue, for child in node left and node right. So if child is not null, notice again, so we're going to first add left and then add right. So this order is important. So once we done this reset of the queue state, we're going to increment the level by 1. So this is the main iterative process. So finally, we are going to return the result. What we want to return is nothing but the final state of the result. So as we can tell, let's first do a special case check. So it passes the first example. Now let's do a generic case test. So it passes the generic case. I guess that's about it for this problem. But so if we print out the level, so actually what we get is the depth of the tree. Let me do this print level. So what we get? We get a 3. So this tree has 3 levels. Or with the tree language, its depth is 2. Some literatures use 3. So in other words, there's a difference by 1. But as long as we know the convention, we are okay to track the level or depth information about this tree. So actually, more complex logic can be added to this piece of code to solve other problems. So this is just one form of writing for a zigzag level order traversal. You are encouraged to explore other methods starting from here. So I guess for this example or problem, that's about it. Thank you.